Alright, so the next section, 5.2, evaluate and graph polynomial functions. Well, when I say and graph, we're not like actually graphing them. It's like knowing what the graph would look like, kind of. So I can't remember if I've written this down in this class before. If I have, you're probably going to be like, oh, here she goes again, because I write it a lot in pre-cal. I don't remember if we've seen it in here. But a polynomial function is a function of the form f of x is equal to a sub n x to the n plus a sub n minus 1 x to the n minus 1 plus dot 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 plus a sub 1 x plus a sub 0. And in this we would say that a sub n is the leading coefficient n is the degree, and a sub 0 is the constant term. Okay, so the a's are just numbers. The x's are obviously the different variables raised to a power, okay, n being the largest power that it could possibly be. Okay, we are going to always want to write it in standard form, okay? If not, a lot of times it will trick you and you'll end up doing a problem wrong. So, standard form exponents are written in descending order from left to right. So what do I mean by that? Yeah. So basically, something like x cubed plus 2x squared plus 5x minus 2 is written in standard form. A sub 0. Right here? It's a 0. It just didn't connect. No, you're good. So this is written in standard form. Okay, because the powers are in decreasing order. Okay, or descending order. However, if I had x cubed plus 4x to the 5th minus 2x plus 7, that's not in standard form, okay? It would have to be rewritten, okay, moving this term to the front, okay, for it to be in descending order. That does not mean every term has to be there, but they have to be in descending order for what is there. Where? Up here? That, it's a 0. It gets a constant term. Do y'all still need stuff that's up here? Okay. I'm not used to what speed y'all write this stuff because I don't normally do this with y'all in the classroom. I do kind of write fast, but I was always one of the first people done with my notes in, like, when I was in class. Because I have a lot of options right in front of me, so it's just grab one. Yes. It's higher than that, because it's AP. I'm going to go ahead and start drawing the chart, but I'm not going to fill it in yet. Does anybody need anything above this point? Yeah. You need 1, 2, 3, 4, 5, 6. You need 6 lines for the actual chart. You don't really need that much space. I just made my boxes really big. These two, you kind of need some space, but the other ones, you don't really need some space. No, this is a different one. These two. You just need more room going this direction. I'm not really going to be writing a lot this way. It's like all one line, but it may or may not fit in my box, and if it doesn't, that's fine. Okay. Alright, well, I'm going to work my way, like, left to right and just start. So the first one is degree 0. Okay. Type is constant. F of x is equal to a sub 0. Example, f of x is equal to negative 14. It's just letting you know, like, what term it is. It basically just means it's a constant term for this one. Yeah, I just random ones. Yeah, it could be anything. It could be 12, 200, 5,000, like whatever. Alright, the next one is degree 1. Is everybody at least down to the chart so I can, like, slide this up? Okay. Type, this is linear. This, like, it looks like a lot of charts, but you don't actually have to, like, use them that much. You don't have to, like, know what they're called. You just need to know how to use them. Which is, like, basically this one, the only thing with this one is you're going to have to basically be able to say what type it is. Which, I mean, you've probably heard most of them before. Probably, like, 2 that you may not have really used before. So. Alright, so a sub 1x plus a sub 0. F of x is equal to 5x minus 7. And after I'm done writing, I can kind of explain this chart too a little better so you understand it. The next one, degree 2, is quadratic. Next one, f of x is equal to a sub 2 x squared plus a sub 1 x plus a sub 0. You know that, like, on an iPad you can do that. You can, like, write with the pencil, and then it'll, like, change it to typing. Once I get the, like, all the chords and stuff set up, I'm probably going to be writing on my iPad and projecting it up there. Because it's really nice. I was very satisfied with my chart the other day. Might have used the ruler app thing on the iPad, but it's fine. It's fine. Still very happy with my chart. Kenny was watching me, like, do it, and he was like, that's really straight. And I was like, thanks. He was like, how'd you get it that straight? And I was like, the ruler. And he was like, you shouldn't have told me that. I was like, okay. I was like, I'm just that good. Just that good at writing a straight line on an iPad. Yeah, once you get to, like, this one, you're going to kind of need to write small. And the next one's going to be one term longer. This looks really scary, but when we do the problems, you're going to be like, this is super easy. The only way it's going to make you cry is if you don't pay attention. Under? Why do you need to go under for hearing aids? You just pop them in. Alright, and the last one is a quartic. Yes.
Oh my gosh, I don't think I can do that one. I had to go under. Is that okay?
I don't care. Quartic. Okay, and then there's going to be some rules that go with these as well, but I'll write those whenever we're done with the chart. Quartic. It's like a quarter, but you just like say ick instead of er. I think Ariel was like one of the only people paying attention when I said that. Math? Well, yes, it can, but alright. Oh, we're still working on the chart, I think. Alright, are we done with this? Oh, well, hold on. I'm going to write this other thing and then I'll come back and explain the chart. Because I did say I would do that. Okay, so basically that chart tells us if something is a polynomial function. If it has that form, okay, any of these forms listed, it is a polynomial function. Okay, but I'm going to give you some things that show you what it's not. But what a lot of your questions are going to ask is for you to say the leading coefficient. Okay, the leading coefficient is the number in front of the biggest powered variable. Okay. It's going to ask you for the degree, okay, which is these things right here. You're not going to have one bigger than, well, let me rephrase. You may have one bigger than that. You could have like x to the 10th, okay, in which case it's just degree 10, but we're not going to like call them anything specific at that point. They do have names, but we're not going to call them that. It has to be written in standard form because if it's not, you're going to have the wrong, well, you're going to end up saying the wrong degree because that's just what happens. Okay, and sometimes we do that to trick you on purpose. Once we do some of these, it'll make a little more sense, so we'll like come back to that in a minute. But it is not a polynomial function if the exponent is negative okay, so something like negative 4x to the negative 3. I don't care. Things that show it's not a polynomial. If I were a teacher. Okay, so the exponent can't be negative and the exponent can't be a variable, so you can't have something like 3 raised to the x. Yeah. Oh yeah, and eventually we'll solve those. It'll be like solve the equation for x, and that will be where x is. It's really easy. That's how you would solve that. That's what x is equal to. Because that is an exponential problem. That is well, for us, 3 chapters away. Technically, it's in chapter 6, but we're going to do trig before we do that. Okay. I love trig. Alright. So, a couple examples of this stuff, and then I'll probably go ahead and intro the stuff that we're going to work on tomorrow so that we have plenty of time to do it. But these problems say to decide whether the function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. Okay, so the degree, type, and leading coefficient stuff is coming from here, other than, well, the degree and type is, leading coefficient obviously is coming from the number. So, number 4, f of x is equal to 6x plus 8x to the 4th minus 3. Yes. Alright. So, I need to first of all, what you should always do is write it in standard form. So, what is standard form? Okay, so this is now in standard form. Okay, and then it says to state its degree, type, and leading coefficient. So, ultimately, we need to say, before we do any of that, is it a polynomial? Okay, yes, it's a polynomial. Because it follows all the basic rules from here. I don't have an exponent that's a variable, and I don't have an exponent that's negative. So as long as it is not one of these two things, there might be something else that comes up, but we'll look at it anyways. We'll look at it in a minute. Okay, so we said it's polynomial, so then what is the degree? Okay, so it's degree 4 because that's the biggest power. I think so. Direct variation? Alright, what is the type? Quartic. Probably not. If you actually write quarter but with an ick, I might laugh and I might give you a bonus point. Alright, and then leading coefficient. Okay, LC is leading coefficient. I just don't like to write out leading coefficient every single time, so I write LC. Yeah, so the reason I always say to rewrite it in standard form first is because a lot of times what I find, and I still got some people on the pre-cal exam, and it kind of made me excited because by now they should know it. Anyways, I did something like this, and a lot of them told me that it was degree 1 and the leading coefficient was 6. But that's not true. Don't do that. Alright. 6 h of x is equal to x cubed square root of 10 plus 5x to the negative 2 plus 1. Okay, is it written in standard form? So it can't be in standard form. Why? Okay, not a polynomial. Negative exponents. So the square root itself is fine, but if if it was like the square root of x, it would not be. So that's another rule we technically could add, but you're not gonna have one like that right now. So that's why I just gave you the rules that you need for this. Because technically the square root of x is x to the 1/2, and you can't have like non-whole number degrees. So that technically is 1. Because it's just a number. Square root of 10 is just a number. Do what? Yeah, so technically speaking, I mean, they do it this way so you don't get confused as to where that x cubed is. But technically this could be rewritten as the square root of 10 and then x cubed. So the square root of 10 is the leading coefficient of x cubed, but we do not have a leading coefficient for this problem because it's not polynomial. Yes. Alright, one more of these and then we'll look at the next thing. G of x is equal to 8x cubed minus 4x squared plus 2 over x. Alright, is this in standard form? Is it polynomial? Why not? Correct, okay? 8x cubed minus 4x squared, and then like Tabitha just said, this x has to move to the top. Okay, we can't have it in the denominator, so that would be 2x to the negative 1, following the rules of exponents from last time. So I now have a negative exponent, meaning it's not polynomial. Yes. Well, it still wouldn't be polynomial because you can't have a variable on the bottom. You can just write like POLY if you want. As long as it's something I can read and understand, I mean, I don't mind you shortening stuff. Okay, so the other two things that are like major in this section that we have to do is evaluating by substitution and evaluating using synthetic substitution. Okay, so by substitution, you've done it before. You probably honestly did it in pre-algebra. You plug in the value of x and solve the equation and just get a number. Okay, synthetic, this is good because they're teaching you synthetic substitution. At some point, it might honestly be in like a section or two, we do synthetic division. Okay, which follows the same exact principle. It's just how you get there. It's basically being able to divide something that's like x cubed plus 2x squared plus 3 divided by x minus 2. Okay, we'll have two methods of which to do that. One being synthetic, which is the easiest, and then the other being long division. Okay, so this synthetic stuff will be very important that you understand this as we do it. We'll do synthetic tomorrow. We're going to do the direct substitution today. Okay, because if you don't understand it now, you're going to struggle with it later. But it tends to be one of people's like favorite thing that we do because it's honestly really easy. Okay. No. Absolutely not. You would take the whole hour and a half and probably more. I was going to say, then you're going to use your calculator. But I'm sure you can find a solver online that's going to do it for you. And I'm sure I can just trust this class not to do that. But all right. So solving by direct substitution. Yeah, this is all, today and tomorrow is all going to be the same section. Alright, solving by direct substitution. So basically, we're going to be given a value of x, and we're given a polynomial function, and we're plugging that value in for x and solving the equation. Okay? Really, really easy. Super easy. Okay? The thing is that you're going to have to remember is that this is another section where you have to read directions. Okay? Some of the problems say you have to do it by direct substitution. Some of them will say you have to do it by synthetic substitution, which we'll look at tomorrow. Okay? No. F of x is equal to 8x plus 5x to the fourth minus 3x squared minus x cubed. And we're told that x is equal to 2. Okay? We're plugging in x everywhere we see an x in the equation. And you do have to show that step. It doesn't really matter for these ones if it's in standard form or not. So f of 2, okay, so 2 is going in for x, that's why I write it as f of 2, is equal to 8 times 2 plus 5 times 2 to the fourth minus 3 times 2 squared minus 2 cubed. Okay, and the reason for the parentheses is to make sure you don't accidentally go in and get rid of negative signs that aren't supposed to be gotten rid of. Okay, so this stuff over here, you just leave it. A lot of people try to go through and divide by 2 at the end because they're like, oh, f times 2. That's not f times 2, that's f of 2. That's saying we're evaluating the function for x being 2. Okay, so leave this part alone. Yeah, don't touch it. Alright, so I'm just literally going to draw an equal sign. I'm not even going to move this down. I'm literally just going to leave it blank on that side. So I'm really not going to touch it. So 8 times 2 plus 5 times, let's do the fourth, 16 minus 3 times 2 squared minus 2 cubed. Okay, now I'm going to simplify it a little bit more. 16 plus 5 times 16. 3 times 4. And simplify it. Okay, and no, you do not get a calculator for this.
What if it's like something big, like, what if it's like 12?
I'm not going to give you any that are that crazy. Does anybody have their book open?
I do.
Who would like number 13? You might want to look at it first. We're going to do another problem, but I'm just saying you might want to look at it first. Alright, 14. G of x is equal to 4x to the fifth plus 6x cubed plus x squared minus 10x plus 5. And x is equal to negative 2. No, I was joking because it had fractions. Alright, so somebody tell me what I need to write here to set this one up. Okay, and this is where the parentheses are really important because the number is negative. You're not going to want to lose the fact that this is negative. And if you just write minus, you might think, oh, 4 minus 2 to the fifth. Okay? Yeah. Alright. Now leave the left side alone and just work on the right side. So what do we got going on here? It's not 36. Eight? You can just go ahead and do all that as one. Okay. Alright, so we understand the concept. I know it's like big numbers, you have to think a little bit, but overall easy, right? Yeah. Okay, I'm going to give you problems. You have like 10 minutes. They're not due tomorrow. Everything for this whole section is going to be due at once on, technically because tomorrow's Wednesday, it will be due Friday. But you'll have plenty of time to work on it, okay, tomorrow as well. But you can knock out these like 4 problems, probably in the next 10 minutes. Purple. Well, on there it does look blue, but it's purple.